All right, so today we're going to look at what are called square numbers and square roots. Now the reason they're called square is because it comes from geometry. If you're measuring the area of a square, you take one side times the other side, right? And what do you know about the sides of a square? They're all equal, right? So what you're doing is you're multiplying a number times what? Times the same number, times itself. Yeah? And that's where the word square comes from. So a square number is the product. Product means you are using what operation, guys? What operation is product? Multiplication. The product of a number, times itself. And it doesn't matter what number, it's just a number times itself. So let's just look at a few examples, and then we're going to make a chart of squares. I expect you to memorize the squares up to 13. Okay? Super easy. Don't worry about it. So let's say I have 2 times 2. What's 2 times 2 going to give me? 4. Therefore, 4 can be described as being a perfect square. Perfect square because it's some number times what? Itself created the 4. Okay? What if I have 9 times 9? What do you get? 81. So therefore, 81 is a perfect square. It's also made up of perfect squares. Because isn't 9 a perfect square? What number times itself makes 9? 3 times 3 is 9. So 9 is also a perfect square. So the two factors in that case were also perfect squares. So again, you get perfect squares by simply multiplying numbers times what? Themselves. Good. Itself. Exactly. Good. So what I want to do is I want to make a chart of squares. Okay? So you start off with what's called the root. The root of the number simply means the thing you're multiplying times itself. Okay? And again, I want you to know all the squares up to 13. Ironically, that's how many lines I had. Okay? I expect these to be memorized. So, now, then you're going to get the squares, and squaring a number simply means multiplying it times what? Itself. Good. And we always start with 1 because 0 doesn't make any sense because 0 times anything is always what, guys? 0. So 0 is not a square, so don't worry about that one. So, going to get the squares. So the first one is 1 times 1, which is what? 1. So 1 is a perfect square. So it's the oddball because you multiplied some number times itself and you get exactly the same number you started with. But that's because it's 1. 2 is 2 times 2, which is what? 4. 3 times 3 makes 9. 4 times 4 makes 16. 5 times 5 is good. 6 times 6. 7 times 7. 8 times 8. Good. 9 times 9. 10 times 10. Good. 11 times 11. Excellent. 12 times 12. Good. 13 times 13. I thought maybe with 1 year y'all kind of taper off because you usually don't go that far. But 13 is really common, so I want you to learn it. So it's just 169. 169. Okay. Now remember, you're not going to be able to have your calculator when you're working with these. So you're going to need to memorize these so that you know exactly what they are. Right? So now we have the root, which means the number we're going to take times itself. Once we multiply it times itself, it's no longer a root. It's a what? a square. And often you'll hear these described as perfect squares. And that simply means they come out to be a nice, even whole number. Right? Because you can do it. If you square to decimal, you get some weird things happening here. So perfect square, square means the same thing. So you'll see them, you'll hear it both ways. Well, if you know the square, all you have to do to find the root of it is simply think what number times itself. So the root, anytime you're asked for the root, think what number times itself makes that square. But if you know your numbers, your squares, then it's easy to find the root just by thinking what number made that square in the first place. So if I ask you to square 6, what would it be? 36. But if I ask you the square root of 36, that just means go the other way. In other words, what number times itself is 36? 6. So do you see the way it works? So if I want the square, that means you multiply the number times itself. If I want the root, that means what number times itself is that number. So what is the square root of 100? 10. Good. Okay. What is the square of 3? 9. Square of 3 means multiply it times itself, right? Okay. What is the square root of 169? 13. What is the square of 7? 49. Okay. So do you see the difference there? If I ask you for the square, that means you want to multiply the number times itself. If I want the square root, then you're going to find out what number times itself made that number. So you're just going back and forth. And that's what we're going to be looking at today. Now, there is a symbol for square root. And the symbol looks a lot like a division symbol. Because if you think about taking the root, what we're really doing is dividing a number to find out what number times itself made that square. So, you see the little root. Now, we're going to talk about the pieces of it. I will not ask you to define them. But as you move forward in mathematics, you're going to need to know the pieces. Okay? The symbol itself is called a radical. Or root. Same difference. Okay? So the symbol is a radical or a root. And if you look, the only difference between a division symbol is it's got that little check mark instead of that curvy line in front, right? Now, the thing underneath is called the radicand. That's the thing you're taking the root of. And again, you don't have to know that term right now, but you will see it later in your life. And the number right here in the little crook is called the index. Now, I know we use indexes to mean exponent as well. Well, it means the same thing. It means what exponent did you put on the number? And you need to know that if there is no index, you're going to assume a 2 or square root. And that's all we're going to be working with in this particular class is square roots. But you could take other roots of numbers as well. But if you mean something other than square root, then you have to put the little number in there. So for example, here, I want not the square root, but the third root, which means a number times itself. How many times you think? 3 times. It's just like an exponent. That's why it's still called an index, right? So, right? Now again, that's beyond the scope of this course, but you're going to see that later. Right? And some of you might want some exercises with those. Just let me know. Okay? So what we're going to do is we're going to go through and we're going to look at some problems. You're going to see that in this book, they are not thinking that this is the number section traditionally the way we do it. So they're going to ask you to do some with your calculator. Just omit those. Don't worry about those. We're going to just do the ones you can do by hand. So let's go to our snowflake. Everybody got this chart and all this information you got going on? Good job. Okay, good. So, here we're talking about square numbers and square roots. Again, a number is squared when it's multiplied times itself. And you see they did part of the chart with the squares and the numbers. Here they're introducing the symbol, square root of A. right? Just means what number times itself would make the thing underneath. So, looking at the exercises here. 1F. Without using a calculator, find the 6th, 9th, and 12th square numbers. Well, that's pretty easy because we just did that, isn't it? Didn't we? Okay. So you can just look at your chart. What is the 6th number? Well, yeah, it's 6, so its square is 36, right? What's 9 squared? 12 squared. There you go. Don't worry about number 2. Why? Yep, using your calculator, who cares about those? So we're not going to worry about those. So look at number 3. This is really interesting and something you need to know because it builds a pattern and allows you to think of things as you move on without worrying about the numbers. The square of an even number. So an even number like 2 is even, right? What's 2 times 2? 4. What's 6 times 6? What do you notice here? The square of even numbers are what? Even numbers, aren't they? They're all divisible by 2. That's what even means. The square of an odd number. So 3 times 3 is what? 9 times 9 is what? What do you notice about those? They're always odd. And that's always the case. So if anytime you square an even number, you're going to get an even number. Anytime you square an odd number, you're always going to get an odd number. Okay? Good. Without your calculator, let's find these numbers. Square root of 49, guys. 7. 7 times 7. Square root of 64. 8. Square root of 121. 11. Square root of 144. 12. You're just going to find out what number times itself. Now, that was pretty speedy. You don't have to be that quick, right? Because some of you don't know that table that well. But you need to get there. Don't worry about 5 with your calculator. The next one, they want to know between which 2 consecutive integers the following values lie. That's a little convoluted question where I'm not going to worry about that too much. So don't worry about that one. Okay? All right. So, how's it look? Finding a square? Square numbers? You're all good? All right. So what I'm going to do is I'm going to stop it. Then I'm going to give you a little assignment. We're simply going to complete these. Any of the ones that don't use a calculator. So just, that's whopping big 7 and 8. Okay? So, and looking at some patterns. And so we can do those. So let me stop the recording.